Hello and welcome back to part 5 of my Unity 3D tutorial for beginners. We've been refining our player movement using a character controller, and now that that's all done, we can start implementing our collectible items that the player needs to pick up. This is a bit of a lengthier process, so I've decided to split it into 2 videos. In this part 5, we'll go over creating some basic animations and implementing sound effects. And in the next video, we'll be using some 3D models from the Unity Asset Store for our items. Make sure to like, subscribe, and share this video if you enjoyed it, and let's get right into it. Alright, so since we're implementing a new feature, let's go ahead and jump into our scenes folder and create a new scene. We can duplicate our current controller scene and name it Collectables. Make sure you double-click on the new scene to open it and check that the name of the current scene is Collectables, as it will look exactly like our previous scene. So in the top left corner, it should say Collectables. Now, in order to make this collectible game object, we're going to right-click in the hierarchy and go to Create Empty Game Object. We can then rename it as Collectible. Now, go to its transform and change its position to a location that you can see easily above the plane. Now, the actual 3D model for the collectible is going to be a child of this empty game object for reasons I'll explain later. For now, we're going to use a basic cube as a placeholder. So right-click on Collectible and go to Create 3D Object Cube and name it Item. To accurately represent the size of our collectible, we'll set the scale to 0.3 in all 3 dimensions. Next, we'll create an animation for this cube by going to Window, Animation, Animation. This will pop up the animation window, which we can drag next to our Project and Console tab. Now, it's prompting us to create an animation, but make sure that you have the parent collectible object selected. Now click Create and name your animation, which I'll name as Rotate, and save. For animations in Unity, we can create what are called keyframes. In other words, values for variables that the object needs to assume at a certain frame. In this case, it will be the transform's position and rotation of the child object. So we can click Add Property, Item, Transform, Position, and add the same for rotation. This is so the animation will determine the child's position and rotation relative to the parent. If we click the big red record button, it'll allow us to set more keyframes automatically. Now, if you see the frame markers, our current animation is 60 frames at a rate of 60 frames per second. For example, if I go to frame 15 and set the Y position to 0.3, it will add a new diamond representing a keyframe at frame 15. So Unity will perform an interpolation, meaning it'll guess where the cube is supposed to be between these 2 keyframes. Now, halfway through the animation cycle, I want to go back to 0. So go to frame 30 and set the Y to 0. Lastly, at frame 45, set the Y to negative 0.3, so that we'll have a cycle of bobbing motion. If we scroll through the animation or press play, the cube will now float up and down. I also want the collectible item to rotate as it's doing this. So let's go to frame 15 and set the Y rotation to 90 degrees. Frame 30 and set the Y rotation to 180 degrees. Frame 45, set the Y rotation to 270 degrees. And then lastly, at frame 60, set the Y rotation to 360 degrees. Now, if we go back and press play, the cube does rotate and bob, but it's not in a very fluid motion. This means we'll have to change the way that Unity is interpolating between these keyframes. Click the record button to turn off recording, and at the bottom of the screen, click on the Curves tab. Now there's a graph that shows the Y position over each frame and the rotation over each frame. We'll have to zoom out to see the rotation as it goes from 0 all the way to 360. We want the cube to rotate at a constant rate, which would imply a straight line. However, as you can see near the edges, it's a bit curved. That leads to some slowing down at the beginning and end of the animation. To fix this, we can right-click on the 360 value at frame 60, go to Tangent, Left Tangent, and set it to Linear. Then we can set the right tangent of our 0, 0 point to be linear by right-clicking on it, going to Right Tangent, and then click Linear. Now if we press play, the cube will rotate at a constant speed, however the bobbing still looks a bit jagged. Since the Y position only changes from negative 0.3 to 0.3, we're going to have to do a bit of zooming in to find it. It's this green curve here, and we want it to look a bit like a sine wave. Now, what I can do is right-click on each of the nodes where it crosses 0 and choose Auto. That will allow me to drag the tangents in a way that looks like a diagonal line. I can do the same for the left and right sides until I get something that looks like this. Do the same for the left, where I get an angle that's a little bit steeper than what I had earlier. Just drag this up a little bit, and we'll get something that resembles a sine wave. Press play, and now the animation looks just as we'd like. Press Ctrl S to save the animation, and if you'd like, you can even go into play mode and see what it looks like in game. Again, it's important to note that the animation changes the child transform, which is relative to the parent. This is because the child will follow wherever I place the parent collectible object. If I were to use a single object and animate its transform, every single collectible would end up in the same spot. Also, the player can jump on top of the collectible, which I probably don't want. That's because our item cube still has its box collider. If I uncheck it, the player will just fall right through. Let's exit play mode and go to the inspector, right-click on the box collider component, and choose Remove Component. Now let's go to the parent collectible object and click Add Component and search for Sphere Collider. The player will collect this item when it touches this sphere. It's not supposed to physically collide with it, so make sure to check Is Triggered. Now when I go into play mode, the player does not collide with the item, however, it still cannot collect the item. To implement collection functionality, we'll have to actually create a script. So go to the collectible, click Add Component, and type collectible, which will prompt us to create a new C# script. Then go to the bottom and click Create and Add. This will create a new C# script called collectible and make sure that it is a component of the collectible game object. For organization, once it's finished building, let's drag the collectible script into our scripts folder. Let's also right-click in our project window, go to Create Folder, and make a folder for our animations, into which we can drag our controller and animation. Navigate to our scripts folder and double-click the collectible script to open it. Similarly to how we used onCollisionEnter to detect when the player hit the ground, we'll use another method that derives from mono behavior called onTriggerEnter. This method will be called whenever another game object touches that spherical collider trigger that we placed around the item. We can check if the item was touched by the player by checking if other.gameObject.name is equal to player. Make sure that it matches the name of the player object exactly, as it is case sensitive. So now all of the code in the body of the if statement will be executed when the player collects the item. For now, we'll just have the collectible disappear by calling destroy game object. Save the script, go back to the Unity editor, press play, and when the player touches the object, it will now be removed from the scene. Frankly, that's a little bit boring, so let's add some special effects that occur when the player picks up the collectible. Next, we're going to add an audio clip that will play when the player picks up the collectible. You can take any MP3 that you may have downloaded or found online and drag it into your project. I chose the Nintendo Game Boy Startup ping, which you can find a link to in the description. To add audio to objects, we can go to Collectible, click Add Component, and search for Audio Source. Once you've added that, you can drag the audio file from your Assets folder into the audio clip slot. Also, make sure you have Play on Wake turned off so that we don't have the audio clip play when the scene starts. In order to get this audio clip to play, we can go back to our collectible script in Visual Studio. In our if statement, we can obtain a reference to the audio source by using getComponentAudioSource and calling its play method with .play. This will play our audio clip whenever the player touches the collectible game object. However, when we go into play mode and test the game, the audio clip does not play. That's because the collectible game object is destroyed before it's able to play the sound. We can add a time delay before the game object is destroyed by going back into our Unity script and adding "1f" in the destroy function. The destroy method takes a second parameter as a float for how much time before the object is destroyed, in this case 1 second. If your sound effect takes 2 seconds, you may want to increase that number to 2. Now when I save the script, go back into Unity and press play, it'll play the sound effect. Now, I'm not much of a fan of how the block just disappears instantaneously when it's collected, so let's add a second animation for when the collectible is picked up. I can go to my Animations tab, click on the collectible parent object, and go to Create a New Animation. I'll go ahead and name it Collected. And once that's done, I'm going to go to the newly created animation in my Assets folder and drag it into my Animations folder. Similarly to what we did for our first animation, I'm going to click Add Property, but this time I'm going to add the child item's transform's position, rotation, and scale. Because I'm going to have this cube speed up its rotation, rise into the air, and shrink until it disappears. So first we're going to press record, click on the item child object, make sure you have the item selected. We'll then go to frame 15 and set the Y rotation to 90 degrees. After that, we can set the Y position to -0.1. That'll cause the cube to sink a little bit before it rises. So at frame 30, let's make the Y rotation 240 and the Y position to 0.15. On frame 45, we'll set the Y rotation to 360 and the Y position to be 0.5. On frame 55, let's try setting a Y rotation of 480 and a position of 0.9. To get the cube to shrink, let's set the scale to 0.2. You can click the little chain link so that all X, Y, and Z will change together. Because we're going to replace this cube with a different prefab, let's set the scale at frame 0 to 1. So now if you preview the animation, it will spin, rise, and shrink. We forgot to set the last frame, so let's go to frame 60, set the Y rotation to 540, the position to 1 in the Y, and the scale to 0.1. It ends up shrinking a little bit faster than I want, so let's go back to frame 55 and set the scale to 0.5 in all X, Y, and Z. Press play again, and the animation looks a bit more fluid, so we can exit record mode and press Ctrl S to save the animation. Now, if we actually play our game, it's not going to play that animation when we pick up the collectible, and that's because we have to edit our animation controller. If you go to the animation folder and click the animation controller called Collectible, it will open a window showing our animation controller. Since we just created our collected animation, there should be a state for that as well in gray. To add a transition to the collected animation, we'll first have to go to our parameters tab and click the little plus in the top right corner to add a new Boolean true or false parameter called isCollected. We'll be able to change this parameter in our collectible script to trigger the new animation. Now to actually create this transition, we can right click on rotate and choose make transition and drag it into the collected animation. We can then go to the conditions tab, click the little plus to add a condition, choose isCollected, and set the value to true. This means that the item will transition to the collected animation when isCollected is true. Now we can go back to our collectible script in Visual Studio, and similarly to what we did for the audio source, we can obtain a reference to the animator by using getComponentAnimator. This will allow us to change the parameters that we set in our animation controller, and in this case, we can use .setBool, enter the name of the parameter, which is isCollected, it is case sensitive, comma, true. If we save the script, go back and play, it looks like the animation doesn't quite play out. We can fix this by going back to the Collectibles animator, clicking on the transition between rotate and collected, and unchecking the box that says has exit time. I also made a mistake making the cube smaller in our initial animation, so click on the animation window and go to its rotate animation and set the scale back to 1. Now if we press play, the cube will start a bit larger than normal, but there won't be that weird change in size between animations. So at this point, we've made our first version of a collectible item script, added some basic sounds and animations, and so make sure to hit that notification bell for the next video where we'll talk about adding some 3D models and some extra effects. Subscribe for more STEM content, and I'll see you in the next video.